Good morning class and welcome back to the first HBL of term 3. Today you'll be looking at chapter 7.1 Pythagoras' Theorem. I hope that you have learned a little bit from the previous two videos. So in a right-angled triangle, the side opposite to the right angle is known as the hypotenuse of the triangle. It is the longest side of the right-angled triangle. In your worksheet 7.1, your first task is to label the hypotenuses of the three triangles given. So as mentioned, it has to be opposite the right angle, and also it has to be the longest side. So for the first triangle, you'll see that it is opposite to the right angle and it is the longest side. The same method is used to identify the hypotenuse for other rotated right-angled triangles as well. So for the second one, you'll find that the hypotenuse is at the bottom. And lastly, you have the hypotenuse over here. Please make sure you fill in your worksheet as we go through this. So the Pythagoras theorem states that the square of the hypotenuse is equal to the sum of squares of the two other shorter sides in a right-angled triangle. Please take note that the Pythagoras theorem only applies in a right-angled triangle. So in this triangle shown here, your C is the hypotenuse. Therefore, C squared is equals to the sum of the squares of the other two sides, A squared plus B squared. Let's move on to the first question. In example 1, it says that in triangle ABC, angle C is 90 degrees, so we know this is going to be a right-angled triangle. AC is 5 cm and BC is 12 cm, and the question wants you to find the length of AB. Let us first draw the triangle out so that you can visualize it better first. So we have a right-angled triangle here. Angle C is 90 degrees. Hence, we know this corner is C. Next, AC is 5 cm. This is the shorter of the two other sides. Therefore, I'll write A over here and label this as 5. Naturally, the last corner will be B and BC is given as 12 cm. So, now that we have drawn this triangle, we want to find what is our AB. AB squared will be equals to the sum of the squares of the two other sides, which is my 5 squared plus 12 squared. Hence, to find AB, I have to square root that sum, which gives me the square root of 169, which gives me 13. You might ask, when we square root 169, we have two possible values, 13 and negative 13. But because we are looking at a length here, negative 13 is automatically rejected. Hence, you need not show it. Let's look at question 2. In the diagram, angle Q is 90 degrees. In this question, the diagram is already drawn for you. PR is 12 and QR is 7. They also tell you that RS is 11. So, for part A, we want to find what is PQ. Similarly, we have to identify the right-angled triangle to apply our Pythagoras theorem in first. So to find PQ, I'll be looking at triangle PQR. PQ is not the hypotenuse of triangle PQR. If you look closely, PR is actually the longest side of this triangle, hence PR is the hypotenuse. Therefore, when I'm finding the shorter side, PQ, I will need to use the square of the hypotenuse to subtract away the square of the other side. Alright? Hence, PQ will be equals to square root of 95, which gives me 9.74679. Do take note that this step is important. You must write down more significant figures first before rounding off to your final answer with 3 significant figures rounding off. Alright, next we want to find PS. Once again, I need to spot which right-angled triangle I'm going to use. So in this case, I'll be looking at triangle PQS. Do take note, you cannot use PRS to solve this because PRS is not a right-angled triangle. Hence, Pythagoras theorem will not apply to PRS. Okay, so looking at triangle PQS, before we can find what PS is, we need to know what our PQ is, which we have found in part A, and what our QS is. So QS is simply 7 plus 11, which is your QR plus RS, giving you 18. Now we can try finding out PS. So the square of PS, which is the hypotenuse, is equals to the sum of squares of the two other sides. So here you can see that I've written my PQ square as 9.74679 square. Why is it that I do not use 9.75? It's because it will be a less accurate answer if you use the rounded off answer. That's why it is important that you write down more significant figures in the previous step, so that if there's another part that requires you to use that value again, you can use a more accurate value. Alternatively, you can also denote PQ square as 95. Why do I say that? Because looking at part A, your PQ is the square root of 95. Therefore, PQ square is essentially 95. Alright, so take note of the accuracy of your answer. Ensure that you use more significant figures first in your working. Now, let's work this out. Alright, sorry, there's a typo error here. This should be PS. So to find our PS is equals to square root of 419, which gives us 20.46948. And finally, we want to round it off to three significant figures, which is 20.5. With this, please try examples 3 and 4 in your worksheets today. Thank you.